Welcome back to another episode of the CSK8 podcast. My name is Jared O'Leary. Each week of this podcast is either an interview with a guest or multiple guests, or a solo episode where I unpack some scholarship in relation to computer science education. In this week's episode, I'm unpacking the paper titled Impact of the Plugged-in and Unplugged Chemistry Computational Thinking Modules on Achievement in Chemistry. This paper was written by Samri Chongo, Kamisa Osman, and Nazrul Anwar Nayan. Apologies if I mispronounced any names. Here's the abstract for this particular paper. Quote, computational thinking, CT, is one of the systematic tools in problem solving and widely accepted as an important skill in the 21st century. This study aimed to identify the effectiveness of the Chemistry Computational Thinking CT-CHEM Module on achievement in chemistry. This study also employed a quasi-experimental design with the participation of 85 Form 4 students in Malaysia. The three types of teaching approaches, namely CT-CHEM Module Plugged-in, CTMP, CT-CHEM Module Unplugged and Plugged-in, CTMUP, and conventional method, CM, were systematically designed and implemented. The achievement of students was measured using an achievement test, where validity and reliability were justified, and two-way ANCOVA was used to analyze the data. Findings confirmed that the achievement of students in chemistry is significantly higher in the CTMP group as compared with the CTMUP and CM groups. Instead, gender had no significant effect on students' chemistry achievement. The study concludes that when students were exposed to teaching and learning strategies by integrated CT through plugged-in strategy, more than a combination of plugged-in and unplugged. Plugged-in visualization activities are more effective in increasing the understanding and achievement of students compared with the combination of plugged-in and unplugged activities. This is because the abstract concept in electrochemistry is easier to understand by students through the visualization activity approach using a computer in explaining the important concepts in the topic, and because the whole content is interrelated. End quote. If I were to summarize this paper into a single sentence, I'd say that this quasi-experimental study investigated achievement outcomes between a chemistry unit in three groups. 1. Chemistry classes integrated with Scratch projects. 2. Chemistry classes integrated with both Unplugged and Scratch projects. And 3. Chemistry classes with no focus on computational thinking. In the show notes, I do include a link to this paper so you can check it out, as well as a link to some of the author Google Scholar profiles if you want to see more of their publications. And you can find the show notes at jaredoleary.com or by clicking the link in the app that you're listening to this on. On my website, you'll find hundreds, if not thousands, of computer science education resources, including well over 100 podcasts at this point. And you'll also find some other nerdy stuff like hundreds of hours of drumming content and some video game content, because I'm that kind of a nerd. Now, if you're interested in Scratch, which is the platform that they discuss in this particular paper, make sure you check out the resources on my website, including the link to bootuppd.org, which has 100% free Scratch curriculum that I continue to develop. All right, before I actually talk about this paper, I want to give a little bit of a caveat. There are some moments in this paper when reading through it where I feel like there were some logic leaps, both in terms of the rationale as well as some of the data. So I'm going to point these out to say I respectfully disagree with this particular sentiment or statement, and I mean no disrespect to the authors when I say it, because I do appreciate the work that they're doing. I think we need more studies that investigate stuff like this, but I don't think we can make some of the assumptions that are made. So for example, in the introduction, the authors mentioned that, quote, science, technology, engineering, and mathematics, STEM, has become a popular term in education worldwide, and chemistry is the center knowledge of science. Thus, students must master it to be competent in the field of STEM, which is the backbone in the development of a country, end quote. A little bit further down on this particular page, quote, accordingly, students must master chemistry, which is the basis in science, to be competent in STEM, as the need to get hold of 21st century skills. The integration of chemistry with computer science is a platform to change the paradigm of students from a user to a creator to generate new ideas in the 21st century, end quote. That's from page 2. Now, I respectfully disagree with this kind of framing of why chemistry is important for STEM. I think chemistry is important in science, and I think the work of chemists is important across STEM, but I don't necessarily think everyone needs to learn chemistry in order to do well with STEM. So for example, I never took a chemistry class. The logic that's kind of expressed here kind of sounds like you can't be a competent chef unless you are also a bladesmith, because chefs use knives in the kitchen a lot, so therefore you need to know how to create the knife. I disagree with that, but I do understand and agree with the importance of chemistry on our daily lives and in relation to STEM. Totally agree. I also agree with the authors who mentioned that the integration of computer science into other domains can be beneficial, and that it's important to teach problem solving in schools, or to at least engage in problem-based learning, and that modeling and simulation is also very important in schools, which are all discussed in the introduction of this paper. Now, the second section of this paper is on literature review. So in this particular section, they discuss how cognitive theory, constructivist, constructionism, project-based learning, and inquiry-based learning were all important for developing the CT-CHEM module. So if you're interested in learning more about each one of those, they have a paragraph on each. But I've also talked about, I think, all of those in different podcast episodes. So you can check those out by going to the CSK8 page on my website and then just sorting by topic, like constructionism. And you can hear more interviews and unpacking scholarship episodes that talk about those. Now, in the literature reviews section, they also mentioned that the two different CT interventions, the one that used plugged in and the one that used unplugged, both used Scratch. The plugged in version had kids going through 3 different Scratch projects that were related to chemistry, whereas the unplugged and plugged version only did 2 Scratch projects, as the time that would have been taken to do the third one was spent doing unplugged activities. So to elaborate on what was discussed in the abstract, there's basically 3 different groups in this particular study. The first group is the conventional method. They didn't talk about computer science, computational thinking. The second group, the plugged in one, used 3 Scratch projects to explore chemistry through computational thinking and computer science. And then the third group used a combination of plugged-in Scratch projects, 2 Scratch projects, with unplugged activities to explore some of the abstract nature of chemistry. Now, here's a quote from page 5 that's under the methodology section. Quote, "In this study, the approach used by the researchers is quasi-experimental design using the pre and the post-test. There are 2 independent variables, which are teaching approaches, 3 teaching approaches, and gender. There are 2 treatment groups for the CT module teaching approach. The first treatment is to integrate plugged-in CT, CTMP, whilst the second treatment uses CT module, which combines unplugged and plugged-in activities, CTMUP, as an approach in teaching. The control group is the group that follows the conventional teaching approach, CM." End quote. So this particular study was done with 85 students who were age 16. 40 of them were male and 45 of them were female. And this was in 3 different public schools in Malaysia. This was conducted over a 6-week period, with each session being about 70 minutes, 70. And the pre and post test consisted of 20 different objective questions, 2 essay questions, and 2 structural questions. And this was all centered around electrochemistry. And the test took about 2 hours to complete, which sounds like a long test. So they administered this test before the unit, and then they administered it after the 6-week period concluded. All right, so let's talk about the findings for this. Overall, they mentioned that, quote, "The findings of the chemistry achievement test by gender are insignificant," end quote. It's from page 8. While statistically insignificant for the total mean between male and female, like males had 44.675, females had 44.022 for the mean. While that is not statistically significant difference, there is a difference between male and female in the 3 different groups, which is interesting. So let's talk about that. So in the control group was the just conventional method, did not do integration with computational thinking and computer science. The mean for males was 36.714, but the mean for females was 46.062. So almost a 10-point difference. Now, what's interesting is these numbers almost flip when you look at the second treatment, which was the one that had the unplugged and plugged. So for this one, the males scored a 45.2 and females scored a 37.929. So again, in the control, males had a 36.7, but then with unplugged and plugged, males had a 45.2. Females, on the other hand, had a 46 for the control and a 38, basically, for the unplugged and plugged. So the numbers almost reverse each other. That is a really interesting finding. It makes me wonder, well, why is it that for females in this particular group, they scored better with the conventional method, but they scored worse with the unplugged and plugged, whereas for males, they performed worse on the conventional method, but better with the unplugged and plugged? That's really interesting. Also makes me wonder, how would this compare for non-binary and trans folks? Okay, now here's the group that I haven't talked about yet. For the first treatment group, that just did the plugged in, so they just did 3 Scratch projects and no unplugged, the males scored a 51.313, and the females scored a 47.533. So both males and females outperformed the other groups. That's a really interesting finding. Now, I do need to say that this is not generalizable. This is with 3 different classes. The findings represent those 3 classes. This does not mean, oh, okay, I need to teach chemistry with Scratch, but it's at least something that's interesting to look at and highlights something that we as a field should investigate more. Why is it that this happened? Now, if we look at the mean, like the combined mean between the different groups, so the authors said that the group that used the conventional method, the mean was a 41.472, and the group that used an unplugged and plugged combination, their mean was a 42.444. That was not statistically significant. So basically means, hey, these are so close that unplugged and plugged didn't really make a difference compared to the conventional method. However, there was a statistical significant difference between those two groups and the group that did the plugged-in version. So the group that did the 3 Scratch projects and no unplugged, they had a mean of 48.624, so about 6 or 7 points higher than the other two groups. And this was found to be statistically significant. That's interesting. Now here's the final 2 sentences from this particular paper. Quote, although the main focus is plugged in, unplugged activities should also be implemented in schools, especially activities outside the classroom. This is because unplugged and plugged-in activities can clearly improve the chemistry performance and the ability in solving problems. End quote. That's from page 12. Now, I respectfully disagree with that particular conclusion based off the findings. It appears as though in the group that did both the plugged and unplugged, they did not have a statistically significant difference between the group that did neither, the control group that just did the conventional method. But maybe qualitatively, the kids had more fun. So if that were the case, then yeah, maybe we should do it. However, it does appear though that for this particular unit and this particular abstract concept in chemistry, working with Scratch on 3 projects was more effective than not working on Scratch, at least when it comes to the scores on this particular test in this particular unit, which gets into a lingering question that I have. Was PBL the reason why the plugged-in group scored higher? So the plugged-in group had 3 projects that they worked on, whereas the unplugged and plugged group had 2, and it wasn't necessarily clear how many projects the conventional method had. So is it more time spent in projects allows you to score higher? If that's the case, how would that compare with a conventional group that had 3 projects that didn't involve computational thinking or computer science? So, for example, you had 3 experiments that you did instead of 3 models or simulations that you created in Scratch. How would those compare? Another thing that I'm wondering out loud is, well, what if kids had more fun engaging with the plugged and unplugged? Even though they might not have scored better, they may have walked away from it going, I like chemistry. Even if it doesn't improve the scores compared to a conventional method, if kids enjoy it more, then maybe we should do that, specifically for the improving enjoyment or interest in chemistry. So another question that I have is, how would the findings change with different chemistry units? So this specifically focused on electrochemistry, but what about a different area of chemistry? And what about a different subject area? For example, if you had done this in an art class, like a group that did plugged in Scratch, a group that did plugged in and unplugged, and then a group that just had a traditional art class, how would those 3 compare on some kind of art measurement? The last question that I have is, why do you think a combination of unplugged activities and plugged activities scored lower than just plugged in activities? The way that unplugged is typically discussed in the field is that, hey, this helps to clarify concepts and it situates it. Like it contextualizes something that is abstract or difficult to understand or comprehend and puts it into a real world context, etc. But in this case, it might not have done that. Was it just because the unplugged activities weren't great unplugged activities? Is it because students were engaged in a novel experience with Scratch and they prefer to spend their time on that, and so they were bored with unplugged? I honestly don't know, and as a field, I think we don't really have consensus yet. So it would be really interesting to do more follow-up studies that looked into some of these different questions. My guess is that it might relate to some of the discussions I've had with some podcast guests on situated language and learning, in that Scratch situated the concepts into a platform that allowed to experiment and model and simulate, whereas the unplugged were too abstract. So they didn't really add to or enhance the learning experience. But that's just a guess. I'll include some links to those episodes in the show notes, so make sure you check those out if you haven't listened to those particular episodes, like the interview with Brian Brown, which was a fantastic interview. If, however, you do have some recommendations of some studies that are similar to this, quasi-experimental design, kind of explores plugged and unplugged versus no CS, I would love to read them. There's a contact me button on my website, jaredoleary.com, so feel free to reach out, especially if you know of any studies that investigate whether or not plugged in versus unplugged increases enjoyment of a subject area. Thank you so much for listening to this particular episode. I hope it raised some questions that you might want to explore in the classes that you work with or in the research that you conduct. But stay tuned next week for another episode, and until then, I hope you're all staying safe and are having a wonderful week.